Okay, so now I want to replicate again the construction of the Gini coefficient from the equal income line and the Lorentz curve in Excel. So I open a Excel file and I first create a column and I call that population quintiles, and maybe I make it a little bit bigger, and it's actually the cumulative population quintiles. Okay, so I'll begin with 0, 20, 40, 60, 80, and 100. Okay, so then we have the equal income distribution line. I just call that equal income distribution line, EIDL. And of course that is 0, 20, 40, 60, 80, 100. And then I create the values for the country, and actually I just called it actual Lorentz curve. Actual Lorentz curve. Okay, so the actual Lorentz curve from the previous example, so 0% of the population have zero income, and then we said 25%, the poorest 20%, they had only 5%, and the poorest 14, only 15, the poorest 60, only 30, and the poorest 80, only 50, and the richest 20 had another 50, so cumulatively they have 100. Okay, so now I want to draw that, so let me maybe create a little bit of space and let me format that cell and let me a little bit wrap the text. Okay, let's see if I get a little bit more real estate. Okay, cumulative population. Okay, so maybe just put that also centered, and maybe let's see if we can put that division maybe centered. Okay, so okay, it looks a little bit better, and we have now a little bit more space. And let's also center it. Okay, so now it should look nice, and we have here a little bit more space to draw the graph. So now I'll just draw the graph. So in Excel, the first column will become the x-axis. So I just go to Insert, Recommended Charts, and then, what I want is something like this, which is like the a line chart. Okay, now let's make that a little bit smaller. And the first thing we want to do is, I don't really need the chart title, so I have a little bit more space, so that it looks similar to what we did in the previous lecture. First thing we want to do is, we want to put the 0 closer to the left. So if you right click on the x-axis, you go to format axis, there's something called on tick marks. So you want this. Then the y-axis, you know, I want to stop that at a maximum of 100. Okay. And I also would like to have vertical grid lines, primary, major, vertical. Okay, so now it looks pretty similar to what we had. And now you see this is fully responsive. You know, if I change it to, let's say, 10, 30, 60, and I don't know, 80, the line would adjust. But let's go back to the original. Okay, so this is our graph, and actually what I want to do is I want to make the numbering a little bit smaller. I don't need this one too, I think it's pretty clear. So I don't need the legend. So but what I want to do is I find those numbers here a little bit too big. Maybe I'll just make that 8. Okay, so okay, but it looks good. Okay, so now I have here another column here, and in here I calculate the area underneath the orange line. So area underneath Lorentz curve. Okay, so Lorentz curve. Okay, and I want to also wrap text. Okay. Okay, so now we have to be careful. Okay, here the first one is obviously 0, but between 0 and 20 for the first we have only a triangle, right? And the triangle is given by this value here, because here we would have a 5. And I don't know, maybe we can actually add some data labels. Okay, so now we have added the data labels here. And so we see the 5. We can add the data labels here as well. Okay, but what matters is the orange line, so we have to look for the 5 here. So now what we do is we say equals 5, but we don't take the 5 from here, but from the actual data, because later we want to change the data points and then adjust it. And then what we want is that the graph automatically adjusts to actual data that we can enter here. So now we have C3 times, okay, 20 over 2, so I just can do times 10. So that will be the first triangle. Okay, so now the second area between 20 and 40, we have first the rectangle. The rectangle has a height of 5, which is basically the height of the previous triangle. So now we say this is equal to the previous 5 times 20, okay, but then we still have the triangle on top of it, so we have to say plus. Okay, so the triangle here on top of it is the distance between 5 and 15, so that's 10. And then again times 20 over 2 or times 10. So now the triangle is always given by this 15 minus this previous 5, so that gives the 10 times 10. Okay, so that's the 200. And now it's always the same. So this formula here, I can copy down. And I'll just copy it down by double clicking that little square here. Okay. So now we have the areas, and you see those are the same numbers that we had earlier. So now what we can do is we just say area under Lorentz curve, and that is just equal to the sum of all those values that we just calculated. Okay, and now I need to, so that's 3000. So now then the area between Lorentz curve and equal income distribution line Okay, so that is equal now to 5,000 minus the 3,000 here, so 2,000. And then we can calculate the Gini coefficient. So the Gini coefficient is now equal to the area between the Lorentz curve and the equal income distribution line. So this divided by 5,000. And now we have a fully responsive dashboard, if you want to. And so now we can change things. Let's say a country is more unequal. Maybe, the poorest 20% have only 2%, and the next 20% or the poorest 40% have only 10%, and the poorest 60% have only 25%, and 80% only 40%. So now you see that the area between the equal income distribution line and the actual Lorentz curve has widened, and we have now, for example, a Gini coefficient of 0.49. And so now we would have a fully responsive dashboard that we can use to illustrate income inequality. Of course, we can actually make that graph a little bit nicer by actually highlighting the area between or underneath the blue line and above the orange line. So let's say I want to highlight that in a nice color. So now what we can do is we first highlight we format the series, and let's say what we can do is format data series, and actually what we want to do is change series chart type, and underneath the equal income distribution line, what I want is actually the area. Okay, so now everything is blue. Okay, but we can change that. Maybe I want to change that to maybe yellow. So I can change, maybe should be able to change that fill to maybe yellow. It's a little bit flashy. Earlier we had it orange, so let's make it orange. But of course now I want to get rid of the orange underneath the orange line, and I can do that by creating another line. I just call that quickly a helper line, just a helper line, and that helper line is always So basically I create another line which is equal to the actual Lorentz curve, and actually no, I should be able, if I highlight at the Lorentz curve, no, I don't need a helper line, so we just right click now and format data series and click on, maybe I get out of the way here. So actually I should have gone to chart type. So format data series. Actually change series chart type combo, and underneath the actual I also want that to be an area. Okay, but now I want that area to be white so that it matches with the background. So I'll just make that maybe white. Okay, it's more gray, I feel. Okay, so now it is white. So now we only see the Lorentz curve. Let's see if I can delete that one. Okay, and so now if I want to, I can create again just another helper line, one for the equal income distribution line, which is the same as EIDL. So I just copy this one, and that's my helper line 1. And then I do another helper line 2, helper line 2, and that is equal to the actual Lorentz curve. So I just copy this down. Okay. And now I can add those hopefully to the graph. So now we go select data, and now we say add series name. Okay, so the series name is, I should have made it visible quickly. I need to quickly get this out of the way. So, okay, make it a little bit smaller for quickly. So we go select data, and now we say I want to add another line. We call that helper line, and the series value, I just read them in by highlighting them. Okay. And so now we can't see that, and that is because it's hidden. But if we shift that up, I think we should be able to see it. We also still have to tell it the horizontal axis. That's actually those numbers here. Okay. So now we also add helper line 2. Add series name helper line 2, and the series values are these. But I got an error message. I don't know, let's do it again. Okay, add helper line, and the series values are these. Okay, then we have to say again that the x-axis is again these. Okay, so now we can nicely format it again. Okay, so first of all we want to get rid of that blue area, so we make that, let's see if I can make that white. Okay, so that's gone. But now I need to show the actual curves again. So let's see what we can do here. Change chart type. So it's still a combo. Okay, so the helper line, we don't want that to be a clustered column. That was just a regular line. Okay. Then the helper line 2 is an actual line. And okay, then the Lorentz curve was an actual line. Okay. So the equal income distribution line, we said this we turn into a area. Okay. Then underneath the actual Lorentz curve, we also turn that into an area. Okay. So, and again, we have to go back again and format the axis by everything with tick marks. And so now we have a nice dashboard where you can see here the green line is the equal and the blue line is the actual Lorentz curve. And again, if we change it back to our original problem, so let's make that again a little bit smaller. So it was 5, I think 15, 30, 50, and 100. And you see everything nicely adjusts, and you can use this in order to make really nice dashboards and visualizations that are interactive, which is also a lot of fun. And of course you could do much more. Let's say if I had the income of a country and the population, then I could use this information to also calculate, for example, the median income. So the median income would be basically between the 60th cumulative percentile, if I divide that by 60% of the population. Actually, let's do an example. So let's say we have a country that has a GDP of, I just come up with a number, 250,000. And it has a population of, let's say, 300. Okay, so now GDP per capita would obviously be, the 250,000 divided by the 300. So 833. But what would be the median income? Well, the median income could be now calculated, maybe a little bit smaller. So the median income could now be calculated as, okay, how much do 60% of the poorest people get? So 60%, okay, so now we would know, so 60%, 60% of the population, I call that 60 income, okay, so if 60% get 30% of total income, so now what we would do is we would say, okay, those 60%, they get so they get 30% of the actual income, right? So we do 30 divided by 100 times total GDP, okay. So that means the 60% poorest, they only get $75,000 out of the $250,000, right? So that means on a per capita income basis, we still have to divide it by 60% of the population. So I just divide by 0.6 times the population, which is 300. Okay. So that means the average income of the 60% poorest is $416. So the next thing we can do is we do the same thing for the 40% income. So I call that for the, I want to know what is the average income of the 40% poorest. So the 40% poorest, they get only 15% of total income. So I do 15 divided by 100 times 250,000. So that means they get only 37,500. Okay, but on a per capita income basis again, per capita among those 40%, I still have to divide by 0.4, 40% of the total population. Okay, so there's something wrong. So 0.4, of course it's E12. So E12. Okay, so now that means the average income of the 40% poorest is only 312. Well, and the median income needs to be the average, the midpoint, between those two. So now you see the gap between GDP per capita and the median income. The median income is only 364, but GDP per capita is much higher. So there's a lot of things that you can do and that you can program, and we can see if we make our distribution again more unequal, holding everything else constant, GDP in the population, what we should see is that the gap between GDP per capita and the median income goes up. So let's do again 2%, 8%, 15%, and 30%, so that's pretty unequal. And you see GDP per capita didn't change, but the median income was pushed down even more. So I hope this gives you a little bit of an idea of what you can do with, just such a simple concept like the Gini coefficient. And yeah, you don't have to really know how to program something like this in Excel, but it's a useful tool, and it's maybe a useful insight for you. I hope you enjoyed it, and maybe some of you feel like, oh, I actually could imagine that I want to become, an economic data scientist, because there are many things you can do. But anyhow, before we get too long, let's just stop here, and I hope you found it interesting. And in the next video, we talk about more philosophical issues related to the distribution of income. All right, so I'll see you hopefully in the next video.